Hello and welcome to Coding with Jess, where you code along with me while I build a thing. If this is your first time on Coding with Jess, welcome. Thanks for coming and hanging out for the next couple of hours. What's going to happen now is for the next couple of hours, I'm going to be working on a project, and I'm actually going to pull up a code editor, and I'm going to be talking out loud while I'm working on things. I'll even turn to the whiteboard at times, which I have right over here, and I have like a camera for us so we can like look at the whiteboard together. Yeah, we're going to do that for the next 2 hours. I'm going to divide my work blocks into 4 25-minute blocks. So we'll do 25 minutes at a time with a 5-minute break in between. Gives me a chance to breathe, gives you a chance to breathe. Nobody wants to watch anything for 2 hours straight except for maybe the Lord of the Rings Extended Edition. Anyway, welcome to Coding with Jess. And without further ado, I'm going to jump right into our topic for the day. And let's see. All right, pull this up. Okay, so today we're going to be looking at a thing called Noosphere. It's probably almost certainly something you haven't heard of unless you manage to wind up here from the actual Noosphere Discord. Also, just heads up too, my computer might be running a little bit laggy. It's a heat thing. Once my air conditioner can bring the temperature down in here, the cores on my CPU will cool and things will speed up. And hopefully that'll happen by the time I'm done explaining what Noosphere is. So, and Chris Joel from Noosphere is actually in the chat. So, that's another thing I should point out is while I'm working, I'm also watching the YouTube chat. So if you interact with me in the YouTube chat, I'll try to glance over there from time to time, say hi, that kind of stuff, and take questions and things like that. Okay, so also, as I mentioned, we're going to do this in 25-minute blocks. So I'm going to go ahead and start a 25-minute timer, and we will kick off work block 1, assuming that my Pomodoro timer can start up. Wow, my computer's running really slow. Yeah, hopefully the air conditioner can do its job. All right, cool. So what is Noosphere? So if you've been following along with any of the stuff that I've written online or any of the stuff I've been doing the last couple of years, you'll know that I'm interested in tools for thought and just this general idea of how do we use our computer to help us think better together. And there's a whole bunch of different directions that you could go within that in terms of user interfaces and representing knowledge better and real-time collaboration are some of the areas that I'm particularly passionate about. But one of the ones that's really interesting is how do we have these tools actually interoperate with one another? This seems like a hard problem. Hey, Mike, I see Mike in the chat as well. Mike and I worked together years back. So how do we help these tools interoperate with one another? This has been something I've been digging into for the last couple of years, and I haven't really seen any compelling solutions to where we are. You might call this like the state of the web today, that we have basically the API problem of like, if you're going to have tools talk to each other, they have to work over GraphQL or REST APIs. And those just aren't, when you get to building those kinds of systems, while it might look promising on the surface, you find out that the integration that you can bring between two different systems is actually fairly minimal. And so Noosphere, I was really interested in exploring it because it claims to be a solution to this problem, at least for the area of note-based tools for thought, although you could possibly extend it to other tools for thought like spatial canvases and that kind of stuff. But if you just wanted to like share information in text files that's formatted in whatever format, Markdown, or they use one called subtext, the Noosphere or the subconscious teams does, or just plain text. How could we share these things in some way? And so Noosphere has a bunch of really interesting properties that promise to help with the problem of interop of tools for thought. So that was interesting. The other thing that was interesting about it for me was that it promises to be decentralized, which is another area where I've been exploring stuff. I currently work at a company called Fission, where we work on sort of decentralized protocols or specifications for building decentralized apps of the future. You could think of it like build the decentralized internet of the future. And I discovered Noosphere because they're actually using one of our protocols called UCAN, which is a decentralized authentication protocol. So when I started digging into Noosphere, what I realized is that Noosphere was a sort of a mishmash of a lot of these technologies that I've been around, but I don't actually really understand how they work. And so by digging into Noosphere, I'm hoping to increase my understanding of Noosphere, certainly, trying to understand whether it solves the problem that it claims to solve of allowing for interoperability or a multiplayer knowledge graph at scale. But I'm also trying to drive my understanding of the underlying technology that Noosphere is built on top of. So IPFS, IPLD, content addressing, some of these other things that I banter about, but I really don't get how they work. So by looking at them in a working system, I'm hoping that I can gain a working knowledge of those systems as opposed to a conceptual knowledge of those systems, which is what I currently have. So that's why Noosphere, that's what Noosphere is. And I thought what we would do to start things out is I thought that I would go to the whiteboard and just absolutely butcher an explanation of what Noosphere is. Now, to be fair, I'm not intentionally butchering it, but I know that this will be an inadequate explanation. I noticed that my camera is off a little bit. Let me turn this on. Webcam settings. That should zoom in a little bit. Oh, looks like it's already zoomed. Okay, so yeah, I'm going to try, there it goes, there it zooms. Okay, so I'm going to try and give an explanation of what I think Noosphere is. And remember that the goal of this work session is actually to increase my understanding of Noosphere. So the understanding that I have now is by definition inadequate, and you should not consider this to be the definitive sort of description of Noosphere. In fact, if Chris has a talk, Chris and Gordon both have talks on Noosphere that are going to be way better at explaining Noosphere than what I'm doing right now. But that's because this is helping me increase my understanding of what Noosphere actually is. Okay, so Noosphere you can kind of think of as operating at several levels. I'm going to start with like the lowest level and the level that I sort of understand, and then we'll like work our way up to like the larger sort of massively multiplayer level. On the very base level of what Noosphere is, you've got your files. And I would say notes, because that's going to be the majority of things are actually going to be notes, but that's kind of where we start. And over here in your files, you actually have stuff that you might want to share on Noosphere. And inside these files, you've got text. And we'll say this one is a .markdown file or something like that. And let's say we've got a whole stack of these. And then you're looking at getting these onto Noosphere and sharing these with someone else. And so at one level, you can think of you will be interacting with Noosphere probably inside of some sort of editor, or the content that goes into Noosphere will be interacting with some sort of editor that's writing out these files. Now, there's an experience that happens inside this editor in terms of like how you would link to other files that we're going to get to, how you would specify whether a file is public or private and that kind of stuff. For right now, and for the sake of this example, I want to ignore those distinctions. And actually, I should mention an important caveat. What I'm trying to accomplish this week and over the next several weeks as I'm working on Noosphere is I'm trying to build a working simulator, or a working simulation, I should say, of Noosphere that actually is end-to-end working as quickly as possible. So I'm not trying to make an accurate, so today we're actually going to have a little editor that changes files. It's not going to be something that anyone would ever use to write files, but it allows me to get that part of Noosphere, the simulation, working as quickly as possible so that I can see how it interacts with all these other pieces. So we're going to elide many of the details as we dive into this explanation of how Noosphere works. Okay, so then one level up from the your files, things go into Noosphere, and then here's where things start to add a little bit of like Noosphere specific stuff. So every file in Noosphere is wrapped in a memo. So let me take one of my files. It's a .markdown file. It's got some content in it. There is this special thing they call a memo. We'll indicate it with like a little letter here. And it has a format to it, which we're going to explore here in a second. And it basically has three things at the top level. One, it has a parent CID And SID's a really important word that we're going to have to come back to when it comes to like understanding how Noosphere works. But we'll come back to that in a second. Parent SID, it has a list of headers, which is basically an arbitrary set of key value things, very similar to HTTP headers or something like that. And then it also has a content SID, which again, that SID word. Right now, what you can think of when you think SID, I think the most important thing to think right now is pointer. It's like it's pointing you to something. Just like if you're familiar with older languages like C++ and that kind of stuff where pointers are a thing, you can almost think of this SID as going to be a pointer value that like gives me a memory location where I can go look up a thing. It's kind of I know that's not going to make a lot of sense for those of you who've been programming in JavaScript all your life. But so here we go, parent SID, headers, and content SID, and this is in a memo. So I'm uploading a file into Noosphere, and then the first thing that Noosphere does is it takes that file, wraps it in, well, it takes that file, it creates a memo for it. What does the parent SID point to? The parent SID points to the previous version. If there is no previous version, I assume that this will be null or whatever the sort of the programming language equivalent of like, there's not a thing here, undefined, whatever is appropriate for the language that you have the implementation of Noosphere written in. The headers are an arbitrary set of key value things. So you might think of things like content type, that kind of stuff are listed under here in the headers file. And then the content SID is interesting. The content SID is actually a pointer to the content of the file. So then where does the file go? The file actually goes onto IPFS, is my understanding. So the content of the file will go out to this, will get propagated to the interplanetary file system. If you're not familiar with that, definitely worth Googling. But the interplanetary file system you can think of as just a decentralized file store, kind of like S3 or something along those lines, where there are nodes running in the cloud hosting all of these files. And the way that you access files in IPFS is by their SID, which stands for their content ID. So you have a content ID, which basically goes and looks up a SID. If you're familiar with hashing and how that works, the simplest way to think about content IDs right now beyond a pointer is to think of it as a pointer address, which is, or think of it as a hash of the content. So in other words, every time you hash the content in the file, you should get the exact same SID or content ID. And so that points to the file sitting in IPFS. All right, so let's back up and like talk about what we've done so far. We had a file, my markdown files on my computer that I was editing with my editor. We uploaded them, published them. I'm not sure what the verbs are here. Like I think this is like an evolving state, but this one of these files is now living in Noosphere, or it's like available on Noosphere. Well, what happens? We immediately divide it into a memo, or wrap it in a memo where we store a parent SID. There is no previous version, so there's nothing there. If you could have like one of the headers could be content type, and you could have content type text/MD. And then the content SID would point, and then we take the file content, upload that file content to IPFS, and store the content SID pointing at IPFS in order to look up that file content. All right, so a question that you might be asking now is, how did where is Noosphere? Like, where does the program running that did this thing that I just mentioned, that uploaded the memo, that wrote the file out to IPFS? And that is running on what they're calling right now a Sphere gateway. And here's where we start getting into some more words that I don't completely understand. Sphere gateway server or something along those lines. They're kind of still, but sometimes it's called just the Sphere, sometimes it's called the gateway server. But the point is, it's a server that's running in the cloud, plain old, they're calling it like a plain old Web 2 server. So it's a server that has an IP address or a URL that I can access, and has a, I think they said a REST API. I don't remember that part. I have to go dig into the details. That part I understood, so I kind of glossed over. I was like, oh, sure. Okay, great. I can talk to it via an API. So I upload this file into to a Sphere gateway. One of the things that's a little bit interesting is that every user gets their own sphere. And so here's where things get a little weird again. What is a sphere? David asks, where is the memo stored? The memo would be stored on the sphere. So that's a really good question, and that's one of the things that our memo contains. So let me, I'm sorry, that our sphere contains. So what does the sphere contain? It contains a couple of things. You can think of the sphere as a data structure, which, by the way, there's a really good guide on this that we should link to, Google Doc, that I've been using to get most of my knowledge about this, including Gordon and Chris's talks. But in thinking through this, there's like basically three things. There's a links, there's notes, and there is names. Links is actually the, all right, let me see if I can get my understanding correctly. Links is a reference from the file name. Yeah. Okay, cool. So to answer your question very specifically, David, the memo, I believe, will be stored in notes. At least this is how I'm building it out. The links is actually a set of references from, well, the memo will be stored in a distributed hash table, which, all right, hold on. Let me back up here. This is where, like I said, this is where things get a little fuzzy. Let me start with what I think I understand. I think I understand what links is. Links is a list of file name to CID mappings. There's that good old CID term again. But the point is, when this markdown file comes in, and I'll use the sort of what has now become the canonical example in my, that is from the explainer doc. Let's say that this markdown file is called cat thoughts, catthoughts.md or whatever. So the title of it is cat-thoughts. And I put this root here just to indicate that, like, yeah, you could just like mark it off, whatever. The name of the file is cat thoughts. Then this in links will store, and there's a reason why we're storing these separately. There'll be cat thoughts and then a reference to some CID. We'll call it X for now, just to have it referenced there. So that's where that sort of file name to CID mapping. Then what does the CID point to? We talked about how this was a pointer. The CID, I believe, points to something in the DHT. And so, wait, I shouldn't just throw on that term DHT without saying more about that. So the Sphere gateway, it has this data structure that stores links, notes, and names. It also has its own sort of internal distributed hash table. And inside that hash table, yeah, this is where I'm a little bit confused about this piece. Basically, you need to use the CID from the file name to look up the memo. So this is like, I should actually probably just say what you have in the links. I know that it's not technically correct to say that, it's technically correct to say that the file name points to a CID, but the important thing is to say that the file name points to a memo. You get to the memo by looking at the CID. That's not the important part. Let me see if there's any, I see some chat going on. Speaking for our Rust implementation, we have a storage extraction over native storage or IndexedDB on the web. And on a native target, it's just a key value store. On the web, it's backed by IndexedDB. Then there's an HTTP-based synchronization flow to replicate stored data between wherever to wherever. DHT is for resolving the pure public key to a CID. A CID can be pulled from IPFS or wherever. Okay, gotcha. So then in that case, like I said, the important thing right here, I'm going to go with the or wherever part of Chris's explanation right there. The important thing is that the file name dereferences to a memo. Running out of whiteboard space over here. And then, so this memo, you can basically look it up by file name. So I can go to cat thoughts, which is then going to give me, actually, let's draw this arrow over to the memo that it points to. All right, so cat thoughts will give me this memo, which will then give me the parent CID, the headers, and the content CID. And what that allows you to do, is that correct? Okay, okay, I think yeah. So we'll get back to notes in a second. But what the links allows you to do is basically look up any link or any note from by name. So you have this way of like a human readable name that allows me to get to a note. Because once I have the human readable name, I get the memo, then I have the content CID, which gets me the note content, as well as any of the headers. So if there's like a title or something like that, I have access to that. Okay, so on to stuff that I understand less. So actually, I'm going to switch just for a second over to desktop and show you what I've got, what some a diagram from the Noosphere explainer, which is very helpful. So the Noosphere explainer has this, here's the sphere, there's links in the sphere, which points to a hash table, HAMT, I'm trying to remember what that stands for. I had to look that up the other day. Hash array mapped tree, which is basically just says, look, for every string, you can get to a CID. And that's what we're trying to do is dereference these strings, skateboarding dogs, zebra facts, cat thoughts, like I had up here on the board, and then get to a CID. And then that CID points to this little structure. This little structure right here is referenced a little bit higher up here with this nice little graphic. Parent CID, inline headers, body CID being the content of the file. And yeah, David, the explainer is public. Trying to figure out where it will be linked from. I think it's linked from the end of Gordon's slides for his talk that he gave in New York 2 months ago, something like that. Unfortunately, I can't post links into YouTube chat, which is awful. I'll drop all these docs into the looks like somebody found their way in. I see their little face appearing up here. But yeah, I'll drop all these links into the README for the GitHub repo that I dropped at the end of the tweet thread. Or somebody, Chris, you could also drop a link at the end of the tweet thread that I posted this morning. That would allow people to get to it. So this little structure kind of indicates the thing I was talking about here on the whiteboard of the parent CID, headers, content CID. And so parent CID, headers, content CID, those three things. And what I think you can think about with the notes, what notes is ultimately, I think you can think of it as sort of the pointer to the top of the file system, is like the best way to think about it, except the file system represented by a set of memos. So yeah, Chris, that's not actually going to work. Your link will get eaten by YouTube's chat. YouTube does not allow any links to get posted. I guess safety, I have no idea. So AMT, so like I was saying, you can think of the notes as like a link to the most recent copy of the file system, or, oh, here's an example that they use, I think further up here in the doc. You can think of this as being the notes as being the CID, which points to the head of a Git repo, right? Like think about how in a Git repo, you have a log of all the changes, and you have a head which points to, head always points to like the current top of the repo. And so you'll have to think of notes as sort of pointing to the top of that file system. And then again, the file system, think of it as a file system composed of memos, not the actual file content. The actual file content will live on IPFS. Okay, so like I said, that's my rough understanding of how links and notes work. We're actually going to build some of this today, and so as we're building it, it will expose further misunderstandings that I have. Since we're like 3 minutes left before the end of our first Pomodoro, what I want to do is jump down to names, because this is a super important thing as well. And then we can take our Pomodoro break, and then we can come back and dive into the code, which is how we want to spend today, writing some code. So names is the last thing. Names is really important because it gives me a way of referencing, I guess they're human readable names of people to public keys. And the reason that this is important is because the public key in some way defines the address of the Sphere gateway server, right? So you got a Sphere gateway server and you can look it up. You can find the Sphere, find that person's note based on their, or notes based on the public key. And then the names allows you, this little names data structure allows you to map names to public keys. So you can think of this as a local address book. Or I guess not address book, but a contact list or something like that. Like it's like, hey, my friend Bob is available at this public key. And as you put people in this names list, this now allows you to go all the way back over here to the editor and do things like at Bob / animal thoughts. So now you can actually reference someone else's note in your inside of a note that you're writing using this, which is the name, and gives you the Sphere gateway, access to their Sphere gateway, and then this, which is the publicly readable name of the file. So once I have access to their Sphere gateway server, I can go look up by the name of the file in their links directory and see if I can find that, which gives me a link to their memo. Giving me a link to their memo gives me a link to the content SID, give me a link to the content SID, gives me a link to IPFS where I can get the content of the file. And at the certain, I can certainly get things like headers from it. I can get the previous versions of it. And assuming that this is a public file, we'll talk about public and private encryption and stuff like that. We haven't even gotten to UCANs and how that works, where you're going to delegate permissions to the gateway server and stuff like that. But I think I'm going to leave UCANs entirely out of the picture for now so that we can get sort of the working simulator working end to end without any authentication or authorization, and then layer on authentication, authorization. But anyway, all of this structure exists so that you can publicly, you can reference other people's notes inside your file. In a way that is like bound to what's local called a pet name system. I can give this public key any name that I want inside my local address book. And this is sort of the idea of Dunbar scale social networking, where it's not like a global name system. It's a local name system that allows me to influence the local things. Whoo! Okay. So we are now at the end of our first 25 minutes. This is my horrible botched understanding of the way that Noosphere works today. And like I said, there's actually a lot of, in that description, there are a lot of things that I understand not very well. Like I don't understand at the implementation level, I understand them at the conceptual level. And so what I'm hoping to flesh out today, after I take a 5-minute break, and you should too, I'm hoping to flesh out the implementation level understanding of each of the things that I put on the whiteboard. So I've got some code that I've been working on for a couple of days where we've got like a basic editor and we've got the memo format and that kind of stuff. And I'll start walking you guys through that when I get back in 5 minutes. Okay, thanks for hanging out. I'll see you guys in 5. Hey, welcome back to Coding with Jess, where we are going to code along on Noosphere today. So we are now in Pomodoro 2 of 4. We've been going for 25 minutes at the whiteboard explaining how Noosphere works, and now we get to actually dive into code, which should be fun. So I'm going to go ahead and hit Start Tomato, start our second 25-minute timer, and let's get going. So there was a lot of great questions and thoughts in the chat, YouTube chat, while I was giving that botched explainer of Noosphere. And I just wanted to point out, I can't drop links into the chat, which is super annoying, but a lot of the information is on subconscious.substack.com. And so through there, you can find a link to the Noosphere, and right at the top, there's a community Discord. So if you wanted to hang out and have some like longer form thoughts, Discord is definitely the place to do it. Huge plug, by the way, I am not on the Subconscious team. I am not on Chris or Gordon's payroll. I just think this is an interesting problem, and so I'm playing with it. But I would, without any prompting, I would say like the Discord server is definitely one of the highest signal Discord server, definitely the highest signal Discord server that I've been on, in just terms of like really smart people thinking about really interesting problems. Very small community right now. It's only like 100 people or so. So great, like I don't often recommend go join another Discord because we're all Discorded to death. But this is actually a good one and a great place to talk about subconscious. All right, so yeah, so this article has some explanation and some diagrams, and then the explainer has some explanation and some diagrams, and then there are 2 talks out there as well. Okay, well, code time. Like I mentioned, I don't want to just have a conceptual understanding of this stuff. I want to actually test my understanding by writing some code to hopefully encode this understanding in code. So what I've got so far, I'm going to show you guys. I have like a little Noosphere simulator. One of the things I really liked from Chris and Gordon's work so far is that the architectural images and explanations are, man, they're so nice. They're just like, they're really well done. And I thought, man, maybe I'll just steal some of that imagery for my simulator. I thought if I could make something where I could dynamically interact with this image, or interact with an editor and see this image change dynamically, I felt like I would have a much better understanding of the system. So it's kind of like being able to like open the hood on a car. You have a much better understanding for like what the car does than when you look at the exterior of the car. And so what I'm trying to do is basically build an animated explainer interactive thing that lets you open the hood on Noosphere and see it do all of the things. Now, necessarily that's going to mean there's like actually a lot of computers, a lot of servers involved in doing all the things for Noosphere. There's IPFS, which has a bunch of nodes running. There's Sphere Gateway servers. There's your local machine. And so in order to be able to visualize what's going on under the hood, I'm going to have to simulate those other computers as just JavaScript programs that are running in the browser. So we'll see how that works. So anyway, let me show you what I have so far. If you want to go check out the code for this, it's available at github.com/jessmartin/ I think it's called Noosphere Simulator. So feel free to go check this out. Right now, it is a Svelte app, which is a Svelte Kit app, which is basically like a better version of React, a lightweight version of React that allows me to like write components and all that kind of stuff. And I should say that I've been working on this for like 2 days. The code is at very much a level of like hacked together state. In fact, I basically have all of the code in one component file. So this is like not the way you should write Svelte. And I've been working on a Svelte app for the last couple of months, and I know how I'm going to eventually refactor this into different components and views. But right now, I just wanted all the code in one place and not have to think about like correctness, but just get it working. And like I mentioned on the whiteboard over here, like my goal is a working simulation end to end as soon as possible, and kind of a mantra that I picked up when I worked at a company called Relevance of like always have working software. So I want to get this thing working and then be able to extend its capabilities and make it more and more complex as I'm working with it. Okay, so let me walk you through what we have so far. I'll start with the UI because I think it'll make more sense what the code is doing. Actually, mapping this code to the whiteboard should hopefully like have some light bulbs for you guys. Okay, so right now, if you go to the UI, you see we have Bob's notebook, and we are looking at a list of notes. And you'll see we have cat thoughts, We have animal thoughts. When you click into cat thoughts, you get the content of the note, which is I love cats. Up here, it changes to the title of the note, like Bob's notebook, cat thoughts. So it's kind of giving you, right now this is I don't have an editor yet in here. Oh, actually, I do. I built this little thing. Forgot I wrote this. So yeah, there's also the ability to add new notes. So I could write zebra thinking, and this is stuff about zebras, and they are gray and white. And then click add note, and then boom, I've got zebra thinking as well. When I click into zebra thinking, I get the note zebra thinking. This is stuff about zebras. They're gray and white. Notice that I'm not yet handling new lines properly, so I'm hoping to get that working as well. And then you can already see I'm starting to dynamically generate this little graphic that they've been using throughout here that references the parent CID, the headers, the body CID, and that kind of stuff. So, so that's what we have so far, just the ability to add notes. The other thing I should point out is that as soon as I refresh this browser, zebra thinking goes away, because zebra thinking is stored in memory in JavaScript. So eventually what I'll probably do is persist these things to IndexedDB. That way you can be working with it in your local browser over time, like close the page, come back to the page, that kind of stuff. And that's all pretty easy to do in Svelte, but I didn't want to mess with that right now. I just want to like get this thing, like I said, working simulation as soon as possible. So then let's look at the code. The code is kind of embarrassingly simple, but you know, part of this doing these live streams every week is getting over my fear of showing the process of like what it takes to actually get something working. So you'll notice that I have a sphere map in JavaScript, or object in JavaScript. That sphere has a title. I was actually curious how titles would be handled in the data structure of spheres, but leaving that aside, I just gave this one a title so that I could throw that up here in terms of like a Bob's notebook. And then I have exactly the data structure which I described on the board: links, notes, and names. You remember I was like, hey, a sphere has links, notes, and names. So we started with that here. And in links, you'll see that I have cat thoughts, which I mentioned. Remember, links are human readable names to CIDs. And since I don't have a CID system yet, I just went with like integers in strings, and maybe we'll add content addressing today. That could be a fun thing to add. It's like actually have real hashes of content using to like make all of our pointers real. We'll see. So, but you see cat thoughts, which refers to 1, animal notes, which refers to 3, and then the way that I'm storing memos, I'm just storing them straight inside of notes. I'm not sure if this is the correct way to do this. If you look at the Noosphere explainer, it shows these this CID here links to this AMT, which I think is like an array mapped try Java, which I do not know what that is. Like I'd have to go read more. I can guess at what that is, but I think it's just like an evolution of the basic map data structure. I'm not sure. And so I don't know where this stuff is actually stored. So right now I'm just embedding it into the Sphere server and having this little array called notes. And you'll notice that each one of these has a CID, or a CID, has the 1 here in cat thoughts links to this 1 here. And like I mentioned, the important thing is that links dereference from file names to memos. It lets you look up a memo based on the file name. And so that's what you can do. You get it's memo number 1, or item 1, I guess, since I'm going for like CIDs type things. And animal notes, same thing, links to item 3. You'll see that these are new files. They have no parent CID, so there's no like previous version. They have a header of title right now. You could add other headers in the future. And then content CID, again, remember like the third little piece of this guy, this content CID or body CID, points to the actual content of the note. And so I have my my awesome implementation of IPFS right here, which we're starting with. IPFS is just an object or a JavaScript map or whatever you want to call it. that allows you to basically a key value mapping between keys, which are eventually going to be CIDs, and the actual values. So here's our I love cats, I love every kind of cat, that kind of thing. So cat thoughts is stored here in IPFS, and then animal notes is stored here in IPFS. So that is effectively the data structures for the entire thing. Right now, we don't have any names because I'm not referencing anything outside. I'm not yet referencing another person's note. So an important, we could do content addressing today, but I think probably a more important thing today would be to get to multiple spheres or multiple notebooks in the browser so that I could switch between Bob and Alice and then like reference Bob's notes from Alice's notes and like be able to follow those links would be pretty cool to see. And then down below that, if you're looking through the repo, this is some view related stuff and some in-page variables that are basically related to doing all this stuff in Svelte. This view related stuff will mostly go away once I like correctly factor this into multiple components in Svelte. But for right now, my HTML is full of a bunch of ifs and elses and around what I should show based on whether these variables or these strings are set to certain values. Not anything you should really worry about. But let's look at add note real quick. So add note, I mentioned that over here, when you bring a file into Noosphere, it creates a memo for you with the parent CID, the headers, the contents, and also uploads that content to IPFS. And so we're basically doing that right here as well. When we get a new note, I am creating the memo here, which has parent CID. Since it's a new note, there's no previous version. I give the new note title as the header. I also created a created header. Why? I don't know. And then the content CID is right there, and I needed to create a random number, so instead of using just regular random numbers, I decided to go with random UUIDs for now, and we can come back to swapping those out. What should be happening right here is create the content ID by hashing the content of a note, and then that would be right here. And then finally, I add the link to the memo to the notes. No, so here's the link. Let me move that up above because that is. Put this up here as well. Oh, actually, this is new CID is the hash of. I think it's the memo. So this would actually be create hash the memo to get another CID, I think. And then, and I see Chris has a couple of comments in here about the HAMT. So I'm going to come back to what is a HAMT and read his comments in just a second, kind of reason those out loud. And then add the memo to the sphere. Yeah, memo and content to the sphere. So then we add the mapping from the title to the new CID here. We add the new CID memo here, and then we add the file content to IPFS, to our fake IPFS. Cool, that's it. And then we just clear the form. So that is really all there's like a fetch note content function in here. So, and then, like I mentioned, there's a bunch of ugly HTML and CSS. I'm using Tailwind to try and format the thing appropriately. So, a bunch of ugly HTML and CSS to be able to get this. And so, from that, you get this really simple data structure that is basically like a single sphere, not able to communicate with any other spheres, but you can add notes, but not edit notes. As soon as we can edit notes, we'll be able to move the parent CID forward. So yeah, pretty fun little program to write, and we'll extend that in a second. Let me read Chris's comments about HAMTs. So in the Noosphere explainer docs, you'll see they reference right here, this is that the links are a HAMT, the notes are an AMT, and then the names are an HAMT as well. So HAMT is hash array mapped tree. Yeah, hash array mapped tree and an array mapped tree. So yeah, Chris is just saying that the HAMT and AMT is basically just a map, but it has properties that make it useful for serializing as IPLD blocks. So IPLD is another one of those buzzwords that I don't yet understand, but would like to understand, that I intend to incorporate into here eventually. And so IPLD has this tricky hard corner. If you want your data to have maximum portability across all the IPFS implementations, you have to chunk it into blocks of bytes with an observed maximum size per chunk. Okay, let me see if he goes on to explain that. A basic map can, nope, he doesn't. That's fine. So IPLD is the block storage layer of IPFS. So we were talking about how IPFS is this distributed storage system. And my understanding, and again, this is a conceptual and not an implementation level understanding, is that IPFS, when you store a file in IPFS, it's stored in these different blocks using the IPLD layer. So like IPFS is like above IPLD, is kind of one way to conceptually think about it. And these IPLD blocks basically allow IPFS to have some really nice IPFS nodes to have some really nice characteristics where you can like subdivide a file into many different blocks and store those file blocks across many different nodes. That's my guess around the way that like the Y IPLD. So apparently HAMT and AMT are special data structures that that allow you to use IPLD to as the block storage mechanism, that kind of thing. And the reason for that, Chris explains, is because a basic map, like plain old map, why not use a plain old map? Why use this like hash array mapped tree? It's because a basic map can easily grow beyond this size. And that raises questions. It can grow beyond the size of the maximum block size that IPLD allows. And that raises the question of like, how do you chunk it up? Like where do you break it down? And to read from the map, like, do you load it entirely into memory and then like iterate over all the possible keys inside the map? Like in a traditional map, you would need the entire map in memory in order to read from it. And so apparently HAMT and AMT partition the key space up so that it can be serialized into blocks nicely. And that doesn't violate the size limit, which allows it to be stored in IPLD, and it allows IPFS to have these nice characteristics where files can be divided across many different nodes. And it makes the storage medium, as Chris points out, much more fungible. Cool. Okay. In that case, are we dealing with real IPFS here? No. Are we dealing with multiple nodes? No. Are things encoded in IPLD yet? No. So we could probably just use a map. Yes. So at the moment, we'll just go with JavaScript maps, and I realize these are actually JavaScript objects. We might actually move to the real data structure called a map at some point in JavaScript. I was just trying to get started quickly, and so here we are. And also, I do think it would be cool. We'll see how far this simulator gets, but it would probably be cool to see if we could actually simulate multiple IPFS nodes running in the browser and a single file getting encrypted in IPLD and like divided across those different nodes. So we may add that level of simulation depending on how much we actually want to learn about the IPFS layer that underlies the storage. Yeah, Chris says, if you have less than 1,000 keys, just use a map. Yep. And we almost certainly will for now. Although that would be interesting too to like stress test this thing. This thing is not meant to be stress test. This is meant to be an interactive interexplainer. And I see Brent's in the chat too. Sup, Brent? Welcome. Brent says IPFS puts the fun in fungible. Yes, IPFS is way more interesting than what I described it as on the board. Okay, so what are we going to do today then? We've got, like I mentioned, there's several different things we could do. There's a lot of different ways that this thing doesn't work yet. One is I can't edit notes. Oh, I know what we should do. We should start by fixing the parent SID, content SID, inline headers. You'll see that these say undefined. So let's jump down to here. This is my really ugly make tailwind, make pretty pictures thingy on the bottom here. So let's see if how I'm fetching the note content apparently is not currently working. So current note is this string. And so when you select a note like animal notes, what I'm going to eventually do this with is actually have, I'm actually going to use URLs for this and use different routes inside SvelteKit. But right now, I'm just doing it using a single route like we talked about and just having current note be stored as a string. So when current note is stored as a string, you can use this fetch note content to get the current note. Oh, and I think fetch note content actually returns the actual content, which is definitely not what we would want. Yeah, that's okay. So that's just me being silly here. What we actually then want is we've got the current note. So I'm just gonna, in the interest of like hacking this thing together and knowing that this function is going to go away once I move to separate once I move to separate routes. So we'll just make a new method. We'll call it fetch note. I'll make this, bump up the size one for you there. And current note gives me the note CID. I don't care about the content CID. So I'm just going to say return. Look in the list of notes, look up by the note CID, and return it. Oops. And whoops. And delete that line. There we go. Okay, cool. So now if I go to cat thoughts, oh, right, I have to swap out the function call as well. So this needs to be fetch note content, that, and all right, now go to cat thoughts. Woohoo! All right, so parent CID is now nil. Inline headers are an object, so we're gonna have to be a little fancier than that. What are we gonna do here? How should I? So I could do things like object.keys. I want the keys and the values of a JavaScript map. So I could iterate over them, and since I know that this is not going to be a deeply nested map, this is going to be just a set of flat keys and values, I might just want to iterate over them and store them as like one inline string. That seems like a reasonable way. I love the way they're represented here, of like with the little tilde and then like showing a list of them. I thought about doing that. I also want to get the nice little dashed lines and the lines here, but that'll be a one day when my brain is like totally fried and I just want to do some UI work. I'll make the little dash lines work and that kind of stuff. But right now I just need to probably display these somehow. So let's see. I wonder if I could do all this inline. So I think there's an each that allows me to do an each key value. JavaScript object each key value. Entries. Yes. Thank you, Dave. That's what I want. I want the one-liner version though, as opposed to having to throw it in here. I guess I could throw it in a function real quick and output the content of that function. But yeah, object. Okay, let me just see what object.entries gives me. I think it might give me an array, which would be good. Dot headers. All right, back over here. Yeah, there we go. Title, comma, cat thoughts. Let me wrap that in a that. Oh yeah, that's gonna be a problem, huh? Huh? How do I escape those? Interesting. Yeah, because in Svelte, that is a reserved character. So how do I output one of those to the, let's see. I could do the Unicode version of, What? Unicode curly brace. There we go. HTML entity is that. I'm sure there's a way to escape that that makes more sense, but that'll be good for now. There we go. Oh, I need the other one, which is left curly brace. HTML entity. Surely it's like 125, 124. It's 123. Yeah, because that makes sense. All right, and we are at the end of this Pomodoro. Let's see, do we fix it? Yay! Cool. Actually, let's make this thing a little wider. There's no reason why it needs to be limited to... why limit it at all? Let me see. There we go. Cool. All right, now we have the parent CID, the content CID, and the inline headers dynamically displayed for each note. The title for this one is Animal Notes. We may want to eventually make that display a little bit prettier. Object entries for each, David says that would be helpful. Whew! We are at the end of our second Pomodoro here, working on Noosphere Simulator. I'm going to take a 5-minute break, and we'll be back for 2 more 25-minute work blocks. So take 5 minutes, walk around, go outside, look up at the trees, far focus your eyes for a little bit. They'll thank you. Work your legs. I'll see you in 5 minutes. Welcome back to Coding with Jess. We are now on Pomodoro 3 for the day. We've been working on Noosphere Simulator for about an hour now, and we're going to spend one more hour in two 25-minute blocks working on our Noosphere Simulator in the browser. So let's go ahead and jump back in. So in the last few minutes, we got this very basic illustration of the memo of the note working. I was thinking about, I think what we should probably do is stop and check in, but there's a couple things we could do real quickly that would probably clean things up. Since this is meant to be an explainer, I do think it's important to make it look good too. And right now our, it's hard to see what's going on here. Whoops. So let's see, let's call this the memo. That should give us, oh, let me permanently put us on the current note page, cat thoughts. There we go. Oh, interesting. Okay, I'm going to do that outside of that div. So this needs to go up here. There we go. Cool. And then let's give this some style to make it a little bigger. Text XL and give a little padding. Margin top, see how that looks. Memo, and let's do font mono to match the rest of the style there, and maybe a font bold. Is it font weight? Ah, there we go. Font bold. Yeah, semi-bold. Cool. All right. And along the line. Cool. So there's the memo. And this is the content up above. Probably not that important to specify that it is the content. One thing we could do is give this border white, border bottom 2, and then give that a little separation. And then we don't need quite as much margin top here. Yeah, that looks not bad, not bad. And then maybe give a little bottom padding here to bottom 2. Overall div. No, it doesn't like that. Now one of those cases where margin doesn't actually do anything. I think it's because of flex. Anyway, all right. Cool. Okay, so now we've got, when we go back, animal thoughts, the memo is separate. What if I didn't make it big? Yeah, there we go. That looks better. And when I get it smaller, cool. Yeah, because I don't think that heading for memo should be larger than the actual content of the file. All right, so there we go. That is those things. Okay, what's next? Okay, well, we've got basically 2 or 3 choices. Well, we've got tons of choices on ways that we can make this better. I don't want to do any like refactoring necessarily. I want to like focus on what can I learn about. And I think given that we have an hour, I had some conversations about content addressing the other day. And so I think what we should do is go through, and since that's like kind of a key, you might have seen me like, there's CIDs all over the place pointing at different things in the system. Since that's like kind of a key way that the system works, why don't we go ahead and switch over to real content IDs from this like bogus indexing thing. And I found out that the way that we need to do that is there is a JavaScript repo called multi-formats. So JS multi-formats has the ability to encode CIDs. Make this a little bigger and more readable for those of you who might be following along on a smaller screen. And so basically what it looks like is something like this. We're going to import CID from multi-format CIDs. We'll import the type of hash that we want to do. SHA-256, and then we will encode our string as bytes. I think that's the one thing I don't exactly understand. This shows you doing it using JSON for things that we're coding that are JSON, I guess. Yeah, we'll see. Maybe there's a codec for yeah, we'll see. Maybe there's a codec for texts. Text. I'm not sure. And then we will call this method content SID to create a SID for it, and we'll get something like this. And so what I'd like to do is go through and replace every reference where we have a bogus SID, a bogus index, or a random UUID, and create those with SIDs instead. So let's do it. Let's see how to grab this and pull it in. We will need to npm install this. Okay, it's not that. Do they have an npm install instructions in here? No, they don't. Okay, jump over to, I mean, I assume this can be used in the browser and not just in like a node type environment, but maybe I'm wrong. Down here, they have some, wait. By default, no base encodings or codec implementations are exposed by multi-formats. You need to import the ones you need yourself. Yeah. So those are the imports. Oh, that's just a bad link. Let's see. npm. What's it on the npm registry as? Oh, just multi-formats. Okay, try that again. Boop, 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 boop. Cool. Chris says he thinks it should be viable in the browser, so let's hope this actually works. All right, so now we should have in our package JSON multi-formats. Cool, there it is. It would go in dev dependencies because everything is a dev dependency. Let's put it in order, MNOP. There we go. And then let's see. We can do an import of the following things. Yeah, that's a good point, David. I could have just looked in the package JSON file. And that would have told me what it is on. The package JSON, or sorry, on npm. Okay, so we've got SID pulled in from multi-formats. We have JSON, if that's what we're going to do, and then SHA-256. What are we encrypting first? So this is going to be interesting. I assume that I can get this JSON. Yeah, should be able to. So the first thing we have is this cat thoughts note. This might be a good time to actually have a function here for okay, sorry. Thinking in my head for a second there. So we could have a function that we end up calling const encode SID, generate SID, something like that. Equals async. It does not need to be async. And we want to generate it for some data. Sure. It looks like we're going to have different ones for different types. So maybe I'll call this generate SID from JSON, maybe. And we know that the, oops, I don't need the import. I need these const. Oh, there isn't a wait in here. So apparently, oh no, we're not in async. It's all good. So then we need to JSON encode the data that we're taking in. And then let's return the CID. And actually for now, let's just console log CID, see how this works. And let's take this first memo and store it as, let's see, cat thoughts memo equals this. And I'll need to move it because it's being defined after it's being referenced. So, oops. Move it up to here. All right, we got a cat thoughts memo, and let's get the CID for it. So the very next thing we'll do is just call, and this is getting really messy. We're getting close to the point where we're going to want to actually refactor this into individual lib files that store these kind of things should live in lib. They should not be in my main script block here, but all good. We're still messing with stuff. Okay, so localhost 5173. If I open up the thingy here, cannot read properties of undefined. Let's see. So we've got our cat thoughts memo, which is it's not JSON. It is an object. So we need like that to JSON. JSON parse. Oh, come on. JavaScript object to JSON. Stringify. There we go. You think I would know all these things by now, but I do not. Let's see. A1. There we go. Cool. So then we need to stringify that object. Data. Generate CID from JSON. Except it's not an object. I should change the name of this now. From object. Passing in data. I'm doing JSON stringify on it. I wonder if I can't do it on more. Did the server already crash? JSON.encode is not a function. Oh. Oh goodness. JSON info. Whoops. Yep, I overrode the name of the import. There we go. Well, that's better. Cannot read properties of undefined reading byte length. Let's try this in the browser real quick. So import those three things. I can't do those imports in the browser or in the console. That's annoying. Let's see. Well, we can try this at least. Let me grab cat thought memo. Maybe the JSON stringify has a problem. I was wondering how it was going to do a deeply nested object like this, but yeah, no problem. JSON. Okay, so that gives us the JSON string, which let's go look at the actual example in the GitHub repo that they show. Let me make this a little bigger. They show a JSON encode. Oh, so they're not using JSON. Wait, No, they are. But they take the straight up object to do it. Like that. Okay. All right. Well, then I need to back that change out. I do want to take data and just straight up encode it. It is generating SID from an object. All right, let me see if that works for us. No, it is still not liking SID create. And that is because we're creating a type 1 SID. That's the first thing that goes in. JSON.code. Oh, that must be like the type. Or the SID creates. That must be the content type code. That's weird. And then the hash itself. Let's at least console log out the hash. Make sure that's working. Ah, it is the dreaded async await. I do need an await around this. Wait that. That means this needs to be async. All right. Now, and we're gonna run into some top level await stuff in a minute here. Great, there's a digest. So it successfully console logged, successfully created a SID. Woohoo! Code is saying what the codec is for the SID, which is DAG-JSON, so that the reader knows the shape of the data that the hash describes. Ah, yes, you're right, and it does handle serializing to string for me, which is that JSON encode, which apparently is some special way of handling it using their codec. Okay, cool. So now we have, we can now generate a SID from an object. This SID is not a string. This is a, so we're going to need to go through one extra step here in order to make the SID a string. Right there, SID to string using an encoder, and I guess we'll just use base 64 because why not? I don't have a strong opinion on this stuff. And then when we parse the SID, we'll have to base 64 decode it. So let me add this import right here, add the base 64 encoder. Excuse me, it came out of nowhere. All right, and I'm really going to want the SID as a string, not an object, I think. So I'm going to go ahead and do SID to string when I return it. And then we will do a console.log of that generate. And hopefully that'll give us the thing we want. Except I have to await. Not top level await. So we're going to end up with const SID string equals await, and that's going to cause me a problem. Yep. Punk. Okay, so the deal is I'm inside of a script block in Svelte, and so far I've just been going line by line and throwing stuff out. And the problem for that is if I have to await on something at the top level, basically I don't have top level await. And so I'm going to get a promise and then have to wait for that to resolve. So now is the point at which I need to actually properly factor this lib file. We'll need to get thrown into. So how would this work? This will be our async function that does it, or that does the generation, and then we'll need to wait for this function to complete before we're able to use the SID to build up the cat thoughts memo. And so what we'll need to do is basically let the page, I think I can do the whole thing inside on mount and get top level await. pretty sure. Life cycle on mount. Yes. Okay, cool. So then what we can do is I'm going to throw this into import on mount from Svelte. And then we can throw this into it on mount async. Wow. Good job, Copilot. Refactored my code for me with one error at make that sit string here, and which was cat thoughts memo. Cool. Okay, so now we should end up with a console log statement. It'll just come a second later. Boom! There we go. Whoo! Just a couple comments that Chris was making based on us going through the content addressing. And since I actually do want to understand how content addressing works, let me read over this real quick and then kind of talk out loud about this. So you'll notice that we had the choice between JSON.stringify and blah 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 blah, and this JSON encode, which basically does the same. Well, it doesn't do exactly the same thing. JSON stringify takes an object and turns it into a JSON string, and then JSON encode takes an object, turns it into a JSON string, and encodes it into a byte array. But what Chris was saying is the multi-format codec does encoding for me because it's really important that when you serialize JSON to a string of bytes, that it be deterministic and consistent across all language implementations. So this JSON stringify might produce different results across different languages and across different implementations in the same language. And if you do that, you basically want your CID, and since think about this, we're doing content addressing, which I guess I explained in a previous video, like my current understanding of content addressing when I was doing Mumbler, but it's when I was mentioning that it's like a hash where you're looking at the actual content of the file in order to generate this hash. If the content of the file differs by even 1 byte, then the hash comes out completely different. And it's really important that you be able to deterministically get a hash from a file or from a JavaScript object, and then it refers to the same thing. Yeah, regardless of which language or ecosystem, you want the same. And so that's why they provide this serializer for you in the multi-formats codec, because presumably it's implemented the same in JavaScript, Rust, whatever language that you're looking at. And presumably like there's some fiddly bits around the specification of how that operates. And Chris goes on to mention that this is why DAG-JSON, which directed acyclic graph JSON, I'm not sure why, is even a thing. It covers edge cases where the same data may be represented differently because of ambiguity in the serialized form. And this is pretty easy to understand. Like you could represent a JSON object as a string in a variety of different formats. Do you include trailing commas? Do you use semicolons? Do you use single quotes or double quotes? Do you use backticks, single quotes or double quotes? Where do you, like, there's all these like idiosyncrasies of, like, imagine a very deeply nested JavaScript object that has lots of different data types in it. When you encode that to string, there's like decisions that have to be made that are not right or wrong. It's just a decision. And so you need it to be exactly the same. So DAG-JSON covers all those edge cases and provides them the same thing. And Chris was giving an example in the chat of, like, foobar and foobar are the same data, and what's the difference? And I think the difference there is that in the example he included in the chat is he included a space between foo after the colon. That's what it looks like anyway, that there's a space. I would have to yep, second one has an extra white space. So that extra white space actually does change change the resulting hash, even though when you convert that to a string, even though they are the exact same JSON, right? They are the exact same copy of a map if you converted it to it. And to give you a quick example of what he was typing in the chat, and then we will take a break here, is he was typing this foo bar. And if I did that, triple equals, which means I'm really, really sure that these things are the same thing, and I add that extra white space, ooh, I get false. Oh, right. That's an idiosyncrasy of the way that works. But anyway, these two things should be the same thing. Yes, and Mike Nygaard mentions that it's the same issue with line endings of, do you have a /n at the end of a line, or do you use a /r/n? They are different in terms of their bitwise, in terms of like what they are represented in the bits at the bit level, but semantically they're the same thing. And so we needed a specification that would allow for the same bits to be generated from the same semantic interpretation. Like the fact that somebody went to all that trouble to work all that out, like I'm very, very thankful that someone has the patience to really pay attention to things, to that kind of fiddly bits, because yeah, you're right, Chris. Triple equal is instance identity. I should have been doing double equal there. Anyway, cool. Let's take 5 minutes. We now at least have a little function to generate SIDs. So my hope is that in this last Pomodoro, the next 25 minutes, I can actually use our SID, and I'm probably going to have to rip it out and put it in a lib file. Anyway, I can use our SID function to generate SIDs for all the things and replace all of our links in our data structure, our sphere data structures and all the memos and everything, with actual CIDs. And then also, when we create and add a note, we can be generating SIDs for the note content and SIDs for the memo, and start using that to like have everything point at each other properly. So anyway, that's what we'll work on when we get back. I'm gonna go take 5 minutes and let my brain clear, and I'll see you guys in 5. Right. Hello, friends. We are back for our last 25-minute Pomodoro for this Coding with Jess session. Um, my voice is starting to go. My brain is starting to fog over. But I feel like yeah, it's been good working through this. I felt like my explanation during the first Pomodoro of how Noosphere works. I feel like I have some new areas that I am aware that I do not understand, which is cool. And some ideas for like how to make this little simulator work. So it's been fun. We've got one more 5-minute or 25-minute Pomodoro put on the clock right now. So we'll do another 25 minutes of this and see how my brain holds up. Chris says this has been amazing. I appreciate it. Do feel like I've been kind of fumbling through things, but it's been fun. So before this in the Pomodoro, we were changing over all of our references in our little internal sphere, Noosphere data structure from these just arbitrary strings to actual content IDs, which are hashes of the object, or in some ways slightly different than the hash, I guess, of the object. So we now have a method in here called generate SID from content from object that'll allow us to generate a SID for any of our objects. I think all we have are objects, except for I guess we might need to generate a SID from a text file. Yeah, from some text content for these guys. So we'll look at that in just a second. But let's see if we can go through and replace our usage of SIDs that point to JSON or objects with this method. One thing we noticed we had to do is because of this hash function here is an async function, we have to wait for it to finish, which means that we needed to make this function async. And because we needed to make it async, we had to put our SID generation into onMount, which allows us to do it asynchronously, since we don't get top level await in this script block. And there may be a way to get top level await in SvelteKit that I'm just not familiar with, but that's where we are. So let's start from the top and work our way down. So the cat thought memo, really this is sort of like seed data. So maybe I'll start organizing this massive script block into different things that we can then kind of extract into different files when I do a refactoring, because this is getting pretty ugly. So let's have our cat thought memo. Wait, but this has a content SID. That content SID, this is text. Need a new content CID from text. So we got our cat thought memo. Let's pull out animal notes memo. Memo equals that. Grab those things and move those up. Again, this content SID that it's referring to is text, and I think we're going to need a new SID from text function for those. We'll find out shortly here. Then I'm going to replace this with animal notes memo. And now what we want to do is we're not going to be able to add things to our sphere except for inside onMount. And then I think this will automatically re-render, like functionally re-render the page. Yeah, it will. Okay, so what we'll do here is, okay, so all the way at the top, we have our seed data, and then for each one of these, we need to get the SID for these guys. So then let's move our seed data inside of onMount. And then we'll need to go remove from sphere our cat thought links. Yeah, that. So now we remove the links. We've removed the memo. Okay, cool. So then the sphere is just going to start out empty. And then inside the sort of generate seed data section, we will create a cat thought memo and then get the cat thought memo CID. And then we'll want to do the same thing for animal thought memo CID, or animal notes memo CID. And then we'll want to add. One thing that's kind of weird is we don't use the, maybe I'll change this title to, doesn't matter. Sorry, being fiddly. Let's add this. So sphere links cat thoughts will now link to cat thoughts memo CID. And I don't know why it did that. Oh, did I not do equals? There we go. So we'll do sphere links that, and then sphere notes cat thought memo CID will include cat thought memo. There we go. That should, let's go see if that worked. Nice. Okay, cool. Now let's do the same for animal notes. We need to go animal notes. That won't be animal notes memo CID. Memo CID equals animal notes memo. Okay, that should give us both of those. Perfect. And let me take us back to the root. Great, animal notes. Okay, so we now, at least for those two JSON file, for the memos, we're now properly encoding things as SIDs. Let's go through and change the way we do SIDs in the add note function. You're passing the wrong content. Let me see, 43. Ah, thank you. Thanks for that catch, Mike. Pair mob programming for the win. Animal notes memo. Yeah, great. Okay, cool. So cat thoughts, animal thoughts. I probably should have let a Copilot generate it. It probably would have done a better job than my copy paste. All right, so now this is for the content ID. Oh man, that's awesome. EH is in the chat. You're totally welcome. It was my pleasure. Had a lot of fun teaching at Lambda School for a couple of years and doing a lot of pair programming with a lot of the students. So yeah, add note. We have, this is the content ID for the text, or content SID for the text, which we don't have a function for yet. So we'll come back to this one. But here's the memo. Did you get the memo? And what we'll need to do here is memo SID, generate SID from object. Yeah, exactly what you thought. Like I said, I should let Copilot do this for me. So we hash the memo to a SID, and then let's change these guys to memo SID and memo SID. Memo SID. And yeah, that should do it. So we should be able to create a new note now. I kind of want to show the SID in the interface somewhere. We should definitely do that because we've done all this work to actually have have these be real SIDs. We should show it. Content type TPS report. Yes. Totally. There's the Office Space reference. Office Space. And did you get the memo? I'm gonna need you to come in on Saturday. Okay, there we go. Add that note and woohoo, pulls it up. Nice. We get the appropriate. Yeah, that's really ugly. I'll need to. Oh look, wait. Oh, that content SID that's garbage. That's a UUID. We're gonna replace that in a minute. We've got this is kind of ugly too, the way that the headers are displayed. So I'm gonna want to clean that up in a minute. But we're getting close. Yes, exactly. That's what I'm thinking, Chris. Chris mentions that the JavaScript has a nice two-string representation. So we're actually already two-stringing this at the end here. We're doing this SID to string base 64. And so we already have a really nice SID or string representation. So let's go ahead and show it in the UI. What we'll do is we'll show it right up here after the note title. So that would be when you're viewing current note. Let's see. If current note is null, that's this. Man, I can't wait to refactor this into separate components. It's going to be so much easier to deal with. Okay, here we go to the note title. We will do fetch current note dot. Oh, how would we do that? I don't think we don't have anything that gives us just the SID. We always bypass the SID. I guess I can get it straight from sphere links instead of using our fetch current. So let's see, sphere dot links current note. That should give us a SID right there. If I hit cat thoughts, yeah, there we go. So there's the CID for that. I don't think I want to use a dot in between. Maybe like make it a parentheses, and I wonder if there's a really easy way to truncate it to like show the first 10 characters or something like that. I'm sure there's a good way to do that in JavaScript. If anyone knows of a good way to do that in JavaScript, feel free to drop it into the chat, because I don't feel like Googling for it right now, because we have 13 minutes left, and I really want to get a function that does SIDs for text. So we have generate SID from object. We're also going to need generate SID from text in order to encode our little files that we're going to toss onto. Actually, this will be interesting. Let's see what Copilot thinks the answer is. Text encoder. This is almost certainly wrong because we need to use the encoding from, we need a codec from multi-formats. So let's go look at multi-formats. And I think they have a list of codecs at the bottom here, maybe. Codecs, multi-base codecs. IPLD codecs. Oh. Okay. Maybe it's just codecs raw? I don't know. I mean, we can try it, I guess. Import star as raw from codecs raw. And then we would do raw.encode. I mean, it feels like raw would be like raw bytes. I do want the JSON codec? Okay. All right. Chris says I want the JSON codec. We're going to go with that. So in that case, I guess I will call the same function, generate SID from object, and just see if it works for our content. So the content is currently stored in IPFS. It's basically just leading bytes that get pre-rendered to the hash. So if you're hashing JSON, it should indicate the JSON codec. But I'm not hashing JSON. I'm hashing like the contents of a file. And which is the answer? Well, I mean, I can always just try it. So let's see. In our on mount here, let's call generate SID from object, and we will pass in just a string. I love cats. I love every kind of cat. And then let's do a console.log of that output without the semicolon in the way. And I think I need to await it like that. Yeah. All right. Well, it does give me a SID. I guess that's okay. We're like, we'll just try it. We'll roll with it. Here we go. So then in that case, we want to start out by taking our cat thought. Let cat thought note equals I love cats. I love cats. Every single day, I love them, love them, love, I love cats. All right, there we go. Oops. All right. I never thought of it that way, David. David says technically just a string is JSON. I guess I always think of it as having to be contained inside curly braces in order to like qualify as JSON, but I guess it is. I guess it's valid JSON. Animal thoughts or animal notes. Yeah. Actually, let me just kill the. There we go. And the last animal notes is I have strong feeling cats. Man, the next feature I'm looking forward to implementing here is links within files, between files. It's actually pretty neat. Okay, so now I need a let cat thoughts CID equal generate CID from object cat thoughts, and I need no wait there. And then same for this next one. Let animal note CID. Thanks, Copilot. And then this will be, and then I need to add, so I need to take them out of this little fake IPFS thing. Move our fake IPFS up above. I don't think it matters actually, but we'll move it right there. And we will use content sub cat thoughts CID equals cat thoughts, and content animal notes CID equals animal notes, and then here in the memo we'll refer to cat thoughts CID, and in animal notes we'll refer to animal notes CID. And then the one other place we need to make this change is down here in the add notes thing. We will take the content, which is what? New note content, I guess? Yeah. So new note fonts to new note content CID equals generate CID from, and we'll need that up above here because we need to refer to it as this new note content CID. Then the memo has its own CID, which we already talked about, which we encode afterwards. And then content new note content CID. Whew, okay. I think that is it. All right. Nothing's breaking over here, which is kind of good. Okay, so cat thoughts. There he goes. A nice little CID there. Go back to the home. Animal notes. There's a nice little CID there. Oh, check it out. There's our content CID right there. So yeah, it appears to be working at least for animal notes and cat thoughts. Are they different? 5W on the end there, QQ on the end there. Yeah, that works. All right, last thing to try is create new notes. The red stapler is mine. Add note, office space. Oh, I forgot to wait. Forgot two waits. And I forgot that this has to be async. All right, let's try that. Create new note. Office space. I wouldn't say that I'm missing it, Bob. All right. I wonder how many Office Space quotes I can come up with. Yes, we got it. It's working. All right, we have the content SID here, and the actual SID for the memo is up here. So you can see like GUW, that's a slightly different ending than this IKG here. Cool. All right. Wow. Cool. So we have a sphere that has links, notes, and names. We have an IPFS, which is just a map. And you can now link all of the things together. So, yay, I did a Noosphere. Cool. So what we've built so far, just to like recap, we've got about 5 minutes left in this session. We have files that have a memo that wraps them. That memo has a parent SID, which currently you can't edit files. So that's something to implement soon, is being able to walk back through file history. Has a set of headers, which act as a key value store, or as like basic key values. And we have a content SID. And then inside our Sphere gateway, we have links, which allow you to dereference a name to a SID. We store the files in IPFS by their content ID and are able to reference the content of that file from our IPFS thing. Then we have a list of notes, which has our basically a big map of all the memos, and we haven't implemented names yet. So yeah, we've got stuff, and you can visualize it as well. So pretty fun. David asks, is Noosphere using IPFS directly, or running their own IPFS nodes, or using something like WinFS Web3 storage? I think the short answer there, and Chris will probably give a fuller answer, is that the Noosphere gateway servers will be IPFS peers. So each gateway server that you connect to, which this is each sphere is basically its own gateway server. So like there's like a one-to-one mapping between you have a notebook, a Noosphere notebook, and you have a gateway server. Each gateway server will be running IPFS as a peer. And it'll also handle things like pinning all your files for you and stuff like that. And I don't think they're using WinFS or Web3 storage or anything like that. Yes. Chris says, we're a standalone implementation. We're decoupled from IPFS, but we talk to IPFS for block syndication, so you can get your data back out of any IPFS node. And this provides like credible exit. And they're hoping to use WinFS when the Rust implementation matures. So yeah, there's an implementation of what you guys are referring to. If you're not familiar with WinFS, there's a library called Web Native. Web Native has a Web Native file system which wraps IPFS to provide things like private files, because IPFS by default everything is public. It also provides an authentication mechanism called UCAN, which gives you the ability to use your keys to encrypt things in that private file system. So WinFS is pretty slick, and I've used it. If you're also, you can go to some of my past live streams. I built a decentralized blogging tool called Mumbler on top of WinFS, and then I've been working on a thing called the Web Native App Template, which is a template for quickly building web native applications, including applications that have a file system. So yeah, you can go check that out too. Wow, super fun. This has been really, I really appreciate you guys hanging out. Chris, I appreciate everything that you and Gordon are doing on Noosphere and with Subconscious. Again, I highly, highly recommend Gordon's writing on subconscious.substack.com if you're into like complexity theory. Mike, I saw you in the chat. If you have not read Gordon's Substack, you would be super interested in it. Definitely deals with a lot of like systems thinking and ecology and other stuff applied to software. So super great stuff. It's been fun to see a possible solution emerging to this hard problem of how do we syndicate our thoughts, our notes, and create this like worldwide knowledge graph. I'm not sure what all the implications of that are, and I hope it at some point in a future live stream to actually explore some of the UI implications. Right now we're looking at sort of the architecture of this system, like how would this system actually work? But at some point we need to explore on the user facing side of things, what does this mean that I can reference these notes? What does it mean that I have like a local address book of people that I can like refer to their spheres? So some really interesting stuff. Dave, Chris, Mike, Brent, thanks for hanging out and hanging out in the chat. It made it way more interesting for me. And now I'm going to go take a nap. So thanks for signing on, for joining for Coding with Jess, and I'll be back next week, probably working on this again. So thanks, guys. Have a great rest of your Wednesday.